For this problem, we want to determine how many of each kind of two different kinds of skis that we need to produce in order to achieve a maximum profit. And to do this, we're going to use a technique called linear programming. We're going to use graphing in order to solve the problem. So, in order to do this, we have two parts to the problem. We have an objective function that we need to maximize, and in this case, that's the profit. So let's go ahead and talk about that right away. So our profit is $50 for downhill skis and $50 for cross-country skis. So our objective function is profit, which equals $50 times the number of downhill skis plus $50 times the number of cross-country skis. I want to write that in terms of x and y because we're going to use graphing here. So I can say that profit, or P, equals 50x, where x is the number of downhill skis, plus 50y, where y is the number of cross-country skis. So there's our objective function, and now we can just hold on to that for the rest of the problem. We'll use that at the end. Next, we have our constraints. So we have constraints on time. We can't use more than 60 hours to manufacture the skis or 36 hours to finish the skis. So in order to write this in terms of x and y, we're going to say that the manufacturing time is 2.5 times x, because x is the number of downhill skis, plus 1.5 times y, the number of cross-country skis, and those have to be, or that total has to be, less than or equal to 60 hours. So it may be that we can get a better profit and use less time than 60 hours. So we don't have to go all the way up to 60, but we're just saying that we're limited by 60. Now we do the same thing for finishing time. For the downhill skis, we only have a half an hour, or we only have a half an hour that we need to finish them. And the cross-country skis take an hour and a half, and so this has to be less than or equal to 36 hours. Now we're also limited by the number of downhill skis and the number of cross-country skis in a way, because those both have to be positive. You can't have a negative number of skis. So x is greater than or equal to 0 and y is greater than or equal to 0. And you see that in just about every word problem, just because realistically you can't have a negative number of things. So we're going to take those constraints and we're going to graph them. We'll see that on the next screen. All right, so here's my graph. Here I have my manufacturing time, and so that's graphed here. My finishing time, and that's graphed here. And I can graph those by using my intercepts. So you can see here I took 2.5x plus 1.5y is less than or equal to 60, and I got my intercepts. So when x is 0, y is 40, and we can see that point. Where is it? Right here. And we've got x is 0, y is 40. And then we have x is 24 and y is 0. So there's 24 comma 0. And then we can do the same thing for the other time, the finishing time. And I have the points 0 comma 24 and 72 comma 0. And I graph the line between those points. And we also have x equals 0 right here along the y-axis. I have y equals 0 right here along the x-axis. And so what I can see is that I now have a shape that's bounded by those four inequalities, and that shape is right in here. So this satisfies all the inequalities, and you can use your test point 0, 0 to check what side you want to be on for the manufacturing and the finishing time. But because it's a less than, you can tell that you're underneath the lines rather than above the lines. So a couple of different ways to tell there. So now that we have this shape, what we're going to do is we're going to look at the vertices of this polygon. And so I have another vertex here, and I don't know the point there yet. I don't know the x and y values. And I have another one here, and of course this is our origin 0, 0. So that very often comes up, not every time, but very often. So I need to get the point of intersection between my two inequalities that we're working with for the manufacturing and finishing times. And so you can use a system of inequalities to solve, a system of equations to solve, or you can graph on your calculator and look for the intersection point. So if you do use the calculator, in order to do this, what you're going to do is, I'm going to put it at the bottom of the screen. Okay, so I'm going to go to y equals and put in for y1, 60 minus 2.5x all over 1.5. y2 is 36 minus 0.5x all over 1.5. Use your parentheses there, so you can type into there. And you're going to graph the system. You're going to make sure that the window is set so that you can see your point of intersection. Well, if you have the regular setup where you go from negative 10 to 10, negative 10 to 10 on the x and y axes, then you're going to miss this point altogether. So in order to view this point, I just look at, well, what x values am I interested in here? I've already got this graph going, and so I can see that I'm only interested in x values between 0 and 24, really. I'm going to just go up to 30 because it's just convenient to go all the way up to 30. And then the same thing for y. I'm going to go from 0 again to 30. Why not? Right? Just include that 24 in there. So this way, now what I'm going to have is basically this window. Right? So everything surrounded in red, kind of went over a little bit there, right, on the sides. You get the idea. So that will be my graphing window. Okay? And then I'll be able to visualize that point of intersection. Now, once I have that and I can see that on the graph, I press second and trace, and that brings me to my calculate menu. Choose intersect and press enter 3 times is really just the quickest way. As long as you only have 2 functions that are entered in y equals, that's all that you need to do, and it will give you your point of intersection. So what you'll see then is that the point of intersection is, all right, so I get the point 12, 20. So x is 12 and y is 20. And now I'm ready to use my objective function. So the only places where we can maximize our profit are at these vertices of our polygon. So we only have 4 pairs of numbers to try for x and y. So let's go to the next screen and do that. Okay, so we have our vertices, which are 0, 0, 0, 24, 24, 0, and 12, 20. And we're going to substitute each of these into our profit function. So for 0, 0, we get 50 times 0 plus 50 times 0. And obviously that's going to turn out to be 0. So this gives us a minimum, and I'm kind of jumping the gun because I'm not comparing it to anything, but I think it's clear that if you make any skis whatsoever, you're going to make more money than if you make none at all. In this scenario where we're assuming that everything that gets made gets sold. All right, so then we can try what if you don't make any downhill skis and you only make cross-country skis? What kind of profit do you make in that situation? So that's 50 times 0 plus 50 times 24, and that gives me $1,200. And because we're selling them for the same amounts, and we have now 24 downhill skis and 0 cross-country skis, so that's also going to give us 1,200. So it doesn't matter if you just stick with one or the other, you make 1,200. Now what if we make 12 pairs of downhill skis and 20 pairs of cross-country skis? In that case, we make $1,600, and that's our maximum. So after all of that, that's the value that we get for the maximum, and that's the end of that problem.